All right, let's move on to adding and subtracting rational expressions. Unlike when we multiply, when we add and subtract, we have to be careful that we have a common denominator, which makes it a little bit more complicated, but it'll be fine. So let's look at this first example. We have, sorry about that. This first example, we have a two rational expressions, and they both already have a common denominator. Okay, so in this case, we're just going to subtract them, and the easiest way to subtract is to actually turn this into an addition problem. And remember, if we're going to turn it into an addition problem, we have to distribute the negative to here and here, to every term after the subtraction sign. So this becomes negative, and this becomes positive. All right. So we already have a common denominator. We just copy down that denominator. Okay, it's going to be the same thing it was. And we're going to now add these. So we have 2x squared plus 3x plus 1 plus negative x squared plus 7x. Okay, I think that this is probably the most common error I see in these problems, is that you'll have a negative 7x right here instead of a plus 7x. But it's because this negative distributed to this negative that we have a plus right here. So just be really careful of that. Now let's look for our like terms, add like terms to finish it out. 2x squared minus x is just x squared. 2x squared minus x squared is x squared. 3x plus 7x is 10x and plus 1. And the denominator stays the same. If you could factor and reduce, you would. In this case, there is no factoring or reducing that we can do. Let's look at the next one. Here we have k squared over k squared minus 1, k squared minus k minus 3, 2k squared, sorry, k squared plus 3k plus 2. We don't have common denominators. Remember, when you're adding and subtracting, you need that. So we're going to start by factoring our denominators to help us know what our least common denominator will be. Okay, so leave the numerator alone, factor this denominator. This first one is a difference of squares. I'm going to go ahead and change this into an addition problem by factoring the negative through, or by distributing the negative through. Either way you want to think about it. Okay, and then let me factor this as well. K plus 1, k plus 2. Alright, so we have certain things in common between the two, and then we have certain things different. I'm talking about the two different denominators. They both have a k plus 1, which is great. K plus 1 in both places. And then this one has a k minus 1, and this one has a k plus 2. So we are going to need all three of these parts, okay, in our denominator, in our least common denominator. Let's call it the LCD. The least common denominator is going to have all three of these parts. The k minus 1, the k plus 1, and the k plus 2. That way, this denominator can fit inside the new denominator here. This denominator could fit inside the new denominator right here. So each denominator is included in this new bigger least common denominator. Okay, so let me rewrite this problem. We have k squared over k minus 1, k plus 1. Okay, k squared over k minus 1, k plus 1, plus I'm going to need to leave a little bit of room, plus negative 2k squared plus k plus 3, negative 2k squared plus k plus 3 over k plus 1, k plus 2. Okay, now let's use our least common denominator. Remember our least common denominator, we were missing in this one, we were missing the k plus 2 part. So if we're going to add in, or really multiply in a k plus 2 in the denominator, we need to do it in the numerator as well. And over here, we're missing a k minus 1, and so if we're going to multiply that in on the denominator, we need to multiply it in on the numerator as well. Okay, I'm going to put some parentheses around this numerator so you can remember to distribute. All right, so let's look at our new our new numerator. Okay, we have k squared times k, so that is k cubed, and then plus 2k squared. Over here we have negative 2k cubed, and then k squared plus 3k, and then plus 2k squared minus k minus 3. And our denominator is this same denominator. I'm not going to rewrite it because I'm afraid of running out of room, but let us go ahead and add up our like terms. I'm going to highlight them just so we can see them clearly. We have some k cubes here. We have some k squareds here, here, and here. And we have some k's, and then we have a constant term. All right, so let's go ahead and write that all out. We have negative k cubed plus 5k squared plus 2k minus 3 all over this same least common denominator that we had before. All right, and you don't need to multiply out the denominator, but you could simplify it if you would like.